All right, welcome to the second of our lessons recorded here at school. So again, any random background noises you hear, I apologize for, though I tried to time this so there are no bells and hopefully no announcements. Let's get started talking about wind energy. So this graph is showing you the percentage of a country's total production for electricity was produced by wind power. Now, the darker green that you see, like right here for Great Britain and a couple of countries in Europe, here and here, they are producing anywhere from 50 to 100% of their power from wind energy. So they're using a lot of wind energy to produce their electricity. Especially big in Europe are offshore wind farms. So they are on the coast, they are in the ocean, actually, uh, uh, you know, like sunk into pylons in the ocean or floating in the ocean, and they are being used to generate a large amount of wind power without using up a lot of land space. You'll see other countries, like for example the United States, we're using somewhere between, looks like about 10 to 20% of our electricity generation is coming from wind. That amount is growing as more wind turbines and wind farms are erected. And there's also some offshore wind farms in the United States as well. We just don't have as much coastline relative to our total land area as some of the countries in Europe do. So, wind energy indirectly comes from solar energy. What happens is the sun unevenly heats the Earth's surface, so some areas are warmer than others, and then that's going to create high and low pressure areas, and that's going to mean that wind is going to be or air is going to move from high to low pressure areas, and that movement of air is what we call wind. If you magically turned off the sun one night, we would not have wind after a while once the Earth's atmosphere kind of evened out in temperature. The best wind speeds you need for wind turbines to be producing peak efficiency of electricity is somewhere between 50 to 60 kilometers per hour. There's actually a minimum speed you need to hit before wind turbines will start actually spinning and generating electricity. And there's a maximum speed above which wind turbines will risk damage if the wind speed is too high. Here you see an offshore wind farm. So these are wind turbines that are anchored in the ocean. Here you see, I wanted you to see the scale of how big these wind turbines are. So here's a person on top of a wind turbine doing maintenance. So these things may not look very big from afar, but they're genuinely huge. Some of the ideal locations for putting wind turbines are the tops of hills, coastal areas, offshore, meaning in the ocean, and open plains where wind can flow unobstructedly. You also need fairly constant, fairly steady wind areas. You don't want an area where the winds will be, dead for a while, no wind, and then gusts of very fast wind coming through, and then no wind. You want fairly steady wind so you can constantly be generating electricity. So, wind turbines are the major way in which we use wind energy to produce electricity, and here's how they work. You have a turbine that utilizes the kinetic energy of air moving to turn a turbine. That turbine directly spins or turns a generator, and that generator directly produces electricity. So you're going straight from kinetic energy to electric energy. It's just kinetic energy of the wind to the kinetic energy of the turbine. Then in the generator gets transformed into electric energy. The average wind turbine will produce about 40 to 400 kilowatts of power. And you need a larger size. The bigger the wind turbine you make or that you use, the more power that you can generate. So ultimately, if you double the length of the blades, and this is a blade, it's what catches the wind and does the turning. If you double the length of that blade, you're going to increase the amount of power that you generate by 4 times. So you're going to have a larger increase than you would expect in the power that's generated. So let's look at the anatomy of a turbine. The average size of the blades is going to be over 170 feet or 52 meters. The largest turbine has blades of about 107 meters long. This is the length of a football field. So a football field long blade, well, three of them usually, are sticking out from a wind turbine. These blades are angled in such a way that when the wind blows directly at them, it'll cause them to rotate. However, if you have these more specialized wind turbines, they have the ability to rotate the blades so that they aren't catching the wind. So if the wind is speed is too high, then they'll feather. That's what it's called when they're rotated. And when they're feathered, they won't catch the wind and they won't spin. So that prevents them from being damaged. So if you see a wind turbine and it's not spinning, that could be one of the issues. The wind speed may be too high. So you have a bunch of mechanical things in here. You do have a controller. You have this big kind of bulge behind the actual turbines that contains the generator and a whole lot of other things is called the nacelle. You have a wind vane and an anemometer. Say that 3 times fast, which measures wind speed because you will then need to either rotate your turbine so you can spin your turbine so that the actual blades of the turbine face a different direction to catch the wind. And you can also have the anemometer measure how fast the wind is going. So if you need to, you can feather the blades so that they're not going to be catching the wind anymore and you don't risk having damage to your wind turbines. Usually wind turbines, the blades are made out of a lighter material like fiberglass or something like that. Some of them may be made with a metal composite. They have the generator in the nacelle, and the generator is being rotated by the wind turbine, and that's what's directly producing the electricity. So, what are some of the environmental effects of wind turbines? Well, they are a renewable and clean source of energy. There are issues with if they are especially in the flight paths or common flight paths of birds or bats. If a bat or a bird runs into the wind turbine, the spinning blades while they're flying, they can be killed. So you have to be careful to place these in areas that may not be common flight paths for birds and bats. Then, wind speed can vary, so you have to have battery storage for when there are times of no wind or low wind speed. And the turbines do produce noise. I looked it up and found out that from a distance of about 300 meters away, it produces a sound slightly louder than like the background hum of a refrigerator. So it does produce noise. And here is kind of our summary. The pros, you get pretty good energy yield from a wind turbine. You can put these wind farms up pretty quickly. You can even build them out to sea, so that way they're not taking up land. While they're operating, they're not producing pollution, especially no greenhouse gases, no other compounds like, nitrogen oxides or anything. A lot of times, these areas where they're located are remote so that they don't interfere with other land use. Like, we don't have to tear down a city neighborhood to build wind turbines a lot of times. That's both a pro and a con. So we're going to look at it as a con in on the other side. And then the land that you have under the turbines, they can't be too close to each other because they'll interfere with each other's catching of the wind. And so they're not going to be so spaced so close together that you can't use the land underneath. So technically, you could use the land underneath for agriculture, perhaps even for raising livestock if you have livestock that aren't sensitive to the noise. The cons, you do need an area with steady wind. Another con, the best locations can be remote, meaning you'd have to build roads and other infrastructure in order to be able to get the turbines out there. And then you've got to build systems to transmit that electricity to where it's being used, mostly cities and population centers. Some people dislike the view of turbines, especially if they're in an area that was really known for, oh, hey, this is a touristy area. Come look at our scenic views. And then if there are some wind turbines plunked there, then all of a sudden it's not so pretty a scenic view. We talked about noise pollution and the harm that can be done to birds and bats. All right, that is the end of this set of notes. Get ready for hydrothermal power next.